Turn our attention to multiplying polynomials. Our main outcome here is we'll look at multiplying one term by two terms by two terms, etc. Our first thing we'll look at is looking at multiplying a monomial by a monomial. Remember that monomials and binomials, you can tell the difference because a monomial is only one term, like this, whereas a binomial would be two terms like x plus 3. And the thing that separates terms is always an addition or subtraction sign. So although there's a subtract here or a negative sign, there's no number or letter in front of that, so this would just be one term. These are two monomials, as are these down here. So when you're multiplying a monomial by a monomial, what you do is you look for multiplying the numbers together. 7 times a negative 3 is a negative 21. Notice I didn't even look at the x's there. I just multiplied the numbers. Now I multiply the variables. When you multiply variables, your exponent rules come into play. So x squared times x to the fifth, multiplying common bases, add their exponents. X to the seventh. Down here, similarly, we've got more letters, but that's okay. It just gives me an extra step. Multiply the numerical coefficients out front. X squared times x cubed would be x to the fifth. Y cubed times y fourth would be y to the seventh. Okay, pretty straightforward multiplying monomials by monomials. Let's try doing a monomial by a binomial. So here's a monomial, here's a binomial. To do this, we use something called the distributive property, where I multiply the monomial out front by each term in the binomial or trinomial or whatever comes after it. So in this case, 2 times 3x would be 6x, and I treat that as a monomial times a monomial. Now I go 2 times negative 4, which is negative 8. Again, I treat this as 2 times a negative 4. Okay, there's the answer for that one. Let's try the next one. Minus 3y times this, minus 3y times that. So minus 3y times a minus 2y, minus times a minus is a plus. 3 times 2 is a 6. Y times y is y squared. Remember, the coefficient would be 1, or the exponent to each would be 1. Multiplying common bases, add their exponents. So that's that times that. Now I have to go minus 3y times 3. Minus 3 times 3 is a minus 9. Y, there's no y there, so I'm just left with the y. Okay, multiplying monomials by binomials. Let's try going binomial by binomial. Here's two binomials, and like what you'd expect, if you look at this one, I'd use the distributive property to multiply the 2 by each term in the binomial. I'm going to do the same thing here, except I've got two things out front here. So I'm going to take the x and multiply it by the other x, and then this x by the 5. And then I'm going to do the 3 times the x and the minus 3 times the 5. So it looks like I'm going to do 4 products here. X times x is x squared. X times 5 is a plus 5x. Minus 3 times x is a minus 3x. And a minus 3 times 5 is a minus 15. Now, once I get my expression here, I want to look for anything that I can simplify. And it looks like these two are like terms, so I need to simplify those. X squared, there's nothing that can go with it, but 5x minus 3x is still a plus 2x minus 15. This would be my answer for that question. Okay, same thing with this one. Multiply the first term by this, and then this by this. Notice that each multiplication involves quite a bit of stuff. Like 3x squared times x, so 3 times 1, there's a 1 out front, would be 3. X squared times x is x cubed. Let's try the next one. 3x squared times minus 7. So 3 times minus 7 is a minus 21. X squared, there's no x's to go with it, so it's x squared. But notice that I have to worry about the sign, I have to worry about the number, then I have to worry about the letters too, for each one of those 4 multiplications. That's quite a bit of work. Okay, let's finish it. 2 times x is be plus 2x, and 2 times minus 7 would be minus 14. No like terms, I'm done there. Why don't you take a second to try some questions on your own. When you're ready, you can press play again and continue on. Okay, one real nice way of checking your multiplication to see if you've done it correctly or not is to graph things. So if I have these as the two that I'm multiplying together, and if this is the answer that I come up with, one of the things I can look at in here for my answer is this y-intercept. The last number here is always my y-intercept. And so when I look at the graph, sure enough, the y-intercept's minus 12. I'm pretty confident that the graph is correct. Another thing you can do is you can graph this one and then graph that one. So graph both of those and see if they match up exactly bang on. If they do, great. One other thing just to address just quickly is the multiplication of squares. Often if I have x plus 4 squared, many students mistakenly just square the x and square the 4 and call it good. Notice I have a not equal to sign there, meaning that this is not right. Can't do it. Don't go this way. Bad things. Where's my red? No, don't do that. A squared means I have 2 of whatever's in brackets. So if I have x plus 4 squared, I'm going to rewrite it x plus 4 times x plus 4. And then I'll FOIL it out. A FOIL, I didn't mention that earlier. You might have heard of that before. That means to multiply the first terms together. X times x is x squared. Multiply the outside terms, which is 4x. Multiply the inside terms, another 4x, and then multiply the last terms. 4 times 4 is 16. That's what FOIL stands for. Of course, this one will simplify the x's, and so the product of x plus 4 squared is this. Notice that what I had in here was close, but I'm missing entirely that 8x term. Don't go this way. No, bad. Okay. The other multiplication that we often see is something called a difference of squares, where I have the same terms, it's just one is plus and one is minus. And we'll see that when we multiply those, we get something called a difference of squares. Let's try multiplying. X times x, x squared. X times a negative 4, negative 4x. 4 times x is a positive 4x. And lastly, 4 times minus 4 is a minus 16. Simplifying, I get x squared is equal to, these two cancel out, so I'll just have a minus 16. And here's where we get this idea of the difference of squares. Here's a square. 16 is the same thing as 4 squared. And so here I have a square, they have a square, and I have a difference of squares. Okay, at this point maybe try some of those. We've looked at in this concept, looking at multiplying monomial by monomial, monomial times binomial, and then binomials times binomials and different flavors of those. It would be a great idea to practice lots and lots of those kind of questions. Again, as always, if you have questions, holler at your instructor.